by demand and with a little bit of a delay, we're having a video on forecasting attendance to national parks. And I'm choosing the Great Smoky Mountains National Park in Tennessee because last night I watched a documentary on Dolly Parton, who is from Tennessee. And now we are too. So with the time series, the method that we need to use when making a forecast is going to depend a lot on patterns and trends in the data. So the first step in forecasting a time series is always to take a look at plots of the data to assess patterns, trends, seasonality. So the first one I'm going to assess, or first thing I'm going to try to eyeball, is whether or not there's a trend in the data. And I'm also going to eyeball that to see if the trend is staying the same over time or if there's different sort of chapters, as they were, to attendance in the Great Smoky Mountains National Park. I'm going to highlight my year and my totals. I'm getting all the way down to 2020. And then I'm going to insert a chart. I'm just going to go for a recommended chart. So here I have total attendance, Great Smoky Mountains National Park, 1979 to 2019. And I'm going to call this park visitation by year. GSM National Park, total visitation by year. I'm not going to worry about labeling the x-axis because it's year and it's pretty obvious, but I'm going to give myself a primary vertical axis label that says annual visitation. Okay, there we go. So what do we see here? Let's zoom in. Let's take a look. I see an upward trend. What do you see? Does it look like it's sloping upward? Does it look like it's sloping upward consistently over time, or does it seem like maybe the rate of increase has increased in the last, maybe decade, maybe since 2011 to 2019, maybe we have a steeper slope than we did beforehand, right? Possibly the park's getting more popular. It is the most popular national park in the country. The second thing that I want to assess, zooming out a bit again, is whether or not there are seasonal patterns to attendance. We can think of season like seasons of the day, but months can also be seasons. Some months are more popular than others, or hours of the day could be a season. Seasonality, it just refers to predictable, repeatable patterns, like a seasonal pattern. We give it that name, but it doesn't have to be the 4 seasons of the year. So I'm going to look at this a couple of ways. The first thing I'm going to do is just look at patterns over the last 5 years. And I'm going to take 2020, even though that data is missing. And I'm going to insert a chart again. I'm going to go for recommended charts. And I'm going to grab, again, a clustered column chart. It's the first one that came up. I'm going to drag it over here, and then we'll zoom in and talk about it. So I'm still going to use the GSM NP, so Great Smoky Mountains National Park, in my title. If I were doing 3 national parks, it would make it really easy to keep track of which was which. But we're going to call this visitation by month and year. I'm not going to worry about, I am going to worry about that axis. I want months on that axis. I'm going to start over because we can get those months there. Let me show you how. Highlight these months, hold down Command, grab the data that we want, insert recommended chart. Yes, it can do it. Don't let it tell you it can't. Same thing, clustered column. Whew. That was touch and go. Now I've got the months on the axis, and the years in the legend. To retitle it. And so here now on this axis, rather than it being annual visitation, I have monthly visitation. This chart shows a clear seasonal pattern. We've got more visitors in June, July, and August, and it appears possibly October. And also in this chart, we can see the pattern of the trend. We can see the trend of increasing attendance in many of these months over time. That mirrors what we see here, which would be an increase between 2018 and 2019. So the last chart I'm going to do is one that just looks at average numbers by month to get a clearer picture of visitation and seasonality. To do that, I'm going to create a row down here that's called seasonal averages. I'm using the word seasonal to talk about months because in this project, the months are my seasons, right? Using the word seasonality in a forecasting sense, the month is the season here. So I'm going to average these by month, by season, same thing. Going to drag it across. Let's see. I've got my actual averages for all months where I have data. And then once I have this effect of COVID that seems to really be kicking in April, I'm going to remove 2020 from my calculation. Why am I doing that? I'm doing that because the COVID numbers are maybe not trustworthy. And then if I want to fill in my estimates here, I don't want my forecasts to be counted in my totals. And so then I'm just going to plot these data. Trying for recommended charts. I'm going to use a column chart. And I'm going to use the same naming convention. GSM, Great Smoky Mountain National Park, attendance by month, visitation by month, let's be consistent. 1979 to 2019, we'll call it. Great. So now we can see, without any noise added by the year, we can see a clear seasonal pattern of attendance to the Great Smoky Mountain National Park. We see a steady increase month by month in the spring. June, July, and August are summer months with a lot of attendance, but we also have September and October with high months. This little spike in October makes me think that maybe we've got some fall colors to see. But we have seasonality clearly in the data, and we have a trend that's clearly in the data. So the forecasting method that I need to do is going to incorporate both seasonality and the trend. Part of the exercise for this activity is to use a deseasonalizing process. So we're going to do that now. So I've got my seasonal averages. In the next row, I'm going to calculate my seasonal indexes. And then in the next column below this, I'm going to calculate an overall average. So here the question for our overall average is, what is the visitation on average each month? I'm going to use the average function. And I'm actually here, I'm going to leave out 2020. I think I've got 2 months of 2020 that I would say would be quote unquote normal. But by February, we were pretty aware of the coronavirus and people were beginning to change their habits in what they were doing. And so I'm going to exclude it because I'm not willing to say that anything about 2020 is normal. So this overall average says that in an average month between 1979 and 2020, on average, 786,906 people visited the Smoky Mountain National Park. So to get a seasonal index, we're going to ask ourselves, what percentage of average attendance happens in each of these months? So in January, attendance is low, right? So it's 274,000 divided by 786,000. We get this low index. On average in January, attendance is 35% of average. That's what that number means. I'm going to go up here and I'm going to give an absolute reference to that denominator. And that's going to allow me to drag all these numbers rightward, giving myself the seasonal indexes for each month. In months where the number is greater than 1, that tells us that those months have attendance that's above average. And you can see that by confirming. You can also sort of see what the above average months are here, and it matches, right? It's June to October. When the seasonal index is less than 1, that means that the monthly average attendance is less than our overall average. So to deseasonalize our data, I'm going to take that as our next step. I'm going to zoom out, if my computer will let me. And I am going to, I could copy and paste this, but there's a shortcut that allows you not have to remake your charts, and that's copying the entire sheet. So I'm going to left click on my tab and then right click, left click, right click, move or copy, and I'm going to create a copy and move it to the end. You tell it okay, and Bob's your uncle, and I'm going to rename this Great Smoky Mountains Deseasonalized. So I want to clear all these numbers out, but before I do so, I'm going to grab my seasonal indices. I'm going to copy them and I'm going to paste them special right into this exact same place, keeping just the values. Now I can clear the contents. I'm actually going to clear the contents from all of this. And now I have my charts, but they're empty, and I'm going to re-seasonalize my data. I'm sorry, de-seasonalize my data. I was way ahead of myself. So to de-seasonalize the data, we take the actual value from our original sheet and we divide it by the seasonal index. So values that are below the average will get made larger, and values that are above the average are going to get made smaller. And I'm going to give an absolute reference to this cell such that the $sign is in front of the row number, but not in front of the column. So there's a $sign in front of the 48, but not in front of the B. And then I'm going to drag this over, and I'm going to drag it down. Or maybe I'll drag it over. Let's see how it goes. And then I'll drag it down. So you see how everything gets turned gray? We're going to fix that in a second. You might already know how, but there's a shortcut. And now I'm going to add in these totals by summing okay, so I'm going to come here and I'm going to highlight this whole section, and I'm going to use what's called the Format Painter. If I click on that and I come back here and I highlight this data, it's going to apply that same format, and I'll get those highlighted, alternate highlighted rows back. Nice, right? You know that's nice. That was exciting. And now we can see that our seasonal averages, our monthly averages are the same, but most of the seasonality has been removed from our original table. And so this allows us to get rid of variation due to seasonality to see only variations due to trends. These numbers are all the same. They're just have different, slightly different decimal places. And I'm going to just adjust this axis. So I'm going to go to a minimum of 200,000 and a maximum of 1 million. And I'm going to have, hi, there's a dog right here. Could you hear him whining? He says, I want to sit on your lap. Yes, you can't sit on my lap. I'm busy. Oh my gosh, I'm struggling. 200 to 1 million. There we go. So now we can see that these are all in fact equal. Okay, now we have done our deseasonalization. The next thing we need to do is figure out the effect, what do we think COVID has done to attendance in this park. So, well, we've got to try something else. We've got to figure out that had COVID not occurred, what is our prediction for the total number of visitors in 2020? That's our next step. So we have a few choices, but when you've got data with trends, as I do here, the forecasting method that works best is linear regression. Both exponential smoothing and moving averages are going to lag behind the trend and they're going to underpredict. And so we have to figure out a linear regression model to forecast total 2020 attendance. You're going to look at your data and you're going to ask it what its story is, and you're going to try a few different things if linear regression is your choice. And I'm going to try two things. I'm going to try using all the data. All the data is sometimes best, but not always. And so I'm also going to try some data that I think might provide a better forecast, which is using just 2011 to 2019. So I'm going to forecast this two ways. And I'm going to merge these cells and I'm going to zoom in so you can see what the heck I'm doing. And this first one I'm going to call reg number 1, 1979 to 2019. And this one I'm going to call reg number 2, and it's going to be 2011 to 2019. And for each of these regressions, I want the slope, the intercept, and the R squared. So I'm going to place those values here. And then I'm going to choose the one with the highest R squared to provide a 2020 prediction as though there were no COVID. And from there, I'm going to do a deseasonalized or deseasonal monthly prediction. All right, let's zoom in a little bit and I'll show you what I'm going to do. So for my first regression is going to use data from 1979 to 2019. And so I'm going to get the slope using the slope function. The Y values in this case are the total annual attendance. And the X values in this case are the years. I am going to just copy those ranges so that I don't have to enter them again. Equals A44. Now I'm really going to have to copy those ranges again. Intercept. And then I can just Command V to put in those data. And then all of these I'm going to get down to a few decimals. So in regression model 1, using all the data, my slope says that on average, annual attendance increases by 58,000 per year, and that the time trend predicts 51% of the variation in attendance. Let's compare this to my next regression. Let's do our slope for 2011 to 2019, 2011 to 2019, 2011 to 2019. I'm going to copy this. Now let's do the intercept and the R squared. I'm going to do a little bit of formatting And now this model that has an R squared of 0.94, it's predicting 94% of the variation in attendance. This is a much stronger model. It's got a slope of 409,061. I love the way this data is formatted, but I can't figure it out. So I've been using Format Painter to get the column in the right place, or the comma in the right place. The second regression is showing a much steeper slope and a much stronger R squared. And that makes sense if you think about it, looking at the plot. Over the last 8 years, the slope has been much steeper than it has over the entire course of the data. So we're going to use regression model 2 that uses only data from 2011 to 2019. And I'm going to use that to predict how many people would have gone to this national park in the absence of COVID. So it's the intercept plus the slope times the year. So I think that in the absence of COVID, borrow my Format Painter tool, which is a really good friend, 12,654,409 people would have gone. And if we remove all the seasonality from the data, we could simplify this and divide it by 12 to get a monthly estimate. So we would get, if there were no seasonality, about 1,054,000 visitors to the Great Smoky Mountains National Park every month. All right, whew, that's a lot of work, right? So here we are. We have, just a quick recap, I'm going to zoom out so you can see what we've done. We started by plotting the visitation to assess visually whether or not there was a trend. Then we plotted visitation by month and year to kind of get a better picture of the trend and to see if some months had more visitation than others. And then we just plotted the average visitation by month to get a really clear picture of the trend. We realized, yes, there's a trend, and yes, there's seasonality. So we used linear regression to forecast what was going to be our estimation of demand in 2020 or visitation in 2020 without COVID. And we deseasonalized the data so that we could get a sense of so that we can play with deseasonalized demand. So if we want to use moving averages or exponential smoothing or any forecasting method on data with strong levels of seasonality, we have to deseasonalize it first. And we've done that. And now what we need to do is estimate. I'm going to copy this. I'm going to zoom in a little bit. So here's our next step, is to estimate using our estimate of 2020 attendance without COVID and our observed patterns of seasonality to provide a forecast of what we think attendance would have been in the absence of, or with COVID, what we think it's going to be for the rest of the year, which is October, November, December. All right, I'm in my second sheet. I am going to copy this data and I'm going to paste it special down here. I just want to give myself a little bit of room. And then I'm going to, format painter, I didn't need to. So now these numbers are just numbers. They're not attached to anything. All right, so projection, no COVID. How's that? I'm going to project when seasonality is removed from the data that 1,054,534 people would be attending this national park each month. Absolute reference it, drag it across, and format painter it. You don't have to format painter it. I just really like it. Okay, so what do I have here? I have actual deseasonalized 2020 attendance and my monthly projected attendance based on my regression if visitation was split up evenly by month. So this allows me to make an assessment of what percentage of my estimate did people actually attend. And I'm just going to call this actual divided by projection. If I could spell it, would make it better. So here in January, we had 1.258 million people visit, but my projection of 2020 attendance, the deseasonalized projection, is 1.054 million. I'm going to just express these in numbers. That number is greater than 1, which tells me that more people attended than my projection allowed for. That's fine. I'm going to drag this to the right, and I'm going to clear these out. And I'm actually going to clear those out because this is what I want to project. So in here, in these numbers, is a story about how COVID affected the Great Smoky Mountain National Park. So if we take a look here at January, in January, attendance to the park was greater than I would have anticipated, even using that very steep slope given in that last few years of the data. February, attendance was higher, but in March, when COVID became prevalent and we started changing our patterns, we saw a decrease in attendance and then a slow increase as it returned to normal, not in a straight line. These are what I sort of would call the COVID months. During this period of time, visitation to the national park has probably been affected by people's perception of safety, et cetera, et cetera, et cetera. But I'm going to use these percentages to forecast what I think is going to happen for the rest of the year. When I look at this, in my mind, I think, well, I have a couple of thoughts. One, where my mind goes is that I think that attendance to the Great Smoky Mountain National Park has rebounded completely. By September, visitation was greater than we would have predicted. With a number of 1.09, it looks a lot like the pre-COVID month. And so I will say, well, I could say that I think we're back to normal. The other thing that I think might be happening that competes in my mind with this is the realization that we are now experiencing another wave of coronavirus. So I don't think that people are going to travel in December as much as they have the rest of the year. So how I'm going to forecast this is I'm going to say that October is going to look like September, fully recovered. But then I think that November and December are going to be a little bit less. I think, in fact, that they're going to look like these months that were more in the center of the pandemic. And I'm going to estimate them both at 0.88. You can choose whatever sort of pattern you want. You just have to be able to justify it. Since October has passed, it's going to look like September, in my opinion. And then I hypothesize that November and December are going to be a little bit lower because of the resurgence in the pandemic. So if those were our forecasted values absent seasonality, what are our attendance values going to look like? So our attendance value would look like our projection percent multiplied by that projection with no COVID. So I'm actually thinking that it's going to be a little bit higher in October, and then it will drop lower in November and December. So I have two forecasts that are caught up in that last step, and I want to highlight them for you. The first forecast that I made here, this is the forecasted attendance percentage. I think that, well, it's not really a percentage, but can I call it that? Will you be okay with that? It's a proportion. If I expressed it as percentages, this would be 109%, that would be 88%, and that would be 88%. I think that actual attendance is going to be 109% of that forecast based on 2020 no COVID. I think it'll be 88% of that forecasted 2020 no COVID and 88% again. So that's my forecasted attendance percentage. That's a proportion. And then this number here is my forecasted deseasonalized attendance. So now we've done two basic forecasted pieces. I can copy these numbers into here. And then I can get a hypothetical deseasonalized 2020 total. So now I have a deseasonalized forecast. We can see my forecasted numbers in the last three columns. I'm forecasting high October, matching the height of September, but then a reduction in both November and December. I'm going to highlight these points in a different color so that we can see clearly. I'm going to go bright red, that they're the forecast. Great, and those are my deseasonalized forecasts. The last thing that I need to do is translate these into seasonal forecasts. To do that, I multiply by my seasonalized index as opposed to dividing. So high attendance months, my deseasonalized forecast will grow as I reseasonalize it. And for low attendance months, my forecast will shrink as I deseasonalize it. Let's see how that looks over here. I'm going to say that my October forecast is equal to the deseasonalized forecast that I have here, multiplied by the value that's in K48. And I can drag that across, and we'll see the updated forecasts. So these are my final reseasonalized forecasts. And here is my finalized estimate of 2020 attendance. If we come back to the charts, I'll zoom back out. I have to reformat this axis, but we can see this point here for 2020 is dropped down, but our axis doesn't extend all the way to 2020. So let's format this. And do we call this a date axis? Do we call it a text axis? What do we call this? Interval between marks 1. Let's see if that does it. No. How do we change that? Let's try it again. Sometimes if it doesn't work, if you try it again, it does. So that's interesting. Text axis. Units 2. We want units 1. Okay, that's going to do it. There we go. All right, now I've got all the years and I go to 2020. And I'm going to format this data point in a different color, that bright red, to illustrate that it's my forecast. So that's my forecasted movement for 2020. We're having high attendance now at the end of the year, but for a couple of months when the coronavirus was first impacting us and people didn't know what to do with travel and were staying at home, the Great Smoky Mountains National Park experienced a decline in attendance. Here, my forecasted numbers for October, November, and December. I think that, well, my forecast is that October is going to be quite high. Maybe I think now looking at it, I think it's too high. I might change it. I'm going to format that data point and I'm going to be consistent here and use bright red to identify my forecasted points. And I'm going to do that for my October, my November, and my December. This is where a code-based statistics program is really useful because you can just write the same piece of code to change all of your charts. And I'm just going to make this the same dimensions as that. And I'm going to zoom out to have the whole picture put together. But this is my forecast for Great Smoky Mountains National Park. I'm forecasting something really high for October. I'm going to come back and check on that in a few months. And lower for November and December. And I had to use my judgment in a couple of places. You'll use your judgment in a couple of places and ask me if you have any questions. All right, happy forecasting.